Whenever we're confronted with a gas mixture problem, which is all the time we have a gas mixture. Every stoichiometry problem is a gas mixture problem. And whenever we're confronted with a gas mixture, the first thing we got to do is, are we looking at this in terms of Daltons, or are we looking at this in terms of Avogadros? That's the first thing you got to do. A lot of people don't do that, and they screw up the calculation, because in some of these calculations, they flip. And so we're going to do a lab, which is a KClO3 decomposition. In the first part of the calculation, we do an Avogadros, and then we flip in the middle of it, and in the second half of the calculation, we do a Daltons. And so we just flip it. And so you got to be able to do the same thing. You flip one way or the other. Which one do you think is more common? Daltons or Avogadros for stoichiometry? Avogadros. Avogadros is way more common. And Avogadros will make your life easy. Avogadros can make your life very easy because of this. So an example of this is 2 hydrogens plus an oxygen gas. There are 2 ways I can make this stoichiometric mixture. One way I can make this stoichiometric mixture is I can just add 2 liters and 1 liter. Or the other way I could do this is for every 2 atmospheres of hydrogen, I have 1 atmosphere of oxygen. Right? And so this would be 2 liters plus 1 liter, that's Avo. 2 atmospheres plus 1 atmosphere, this would be Daltons. And it depends on how you do this, because both ways are done. Both ways are done. Some people will get a container and then just inject hydrogen, 2 atmospheres. And then in the same exact container, inject oxygen, 1 atmosphere. Okay? Or then get a box, 2 liter box of hydrogen, and mix it with a 1 liter box of oxygen. Right? Well, if I do that, how many liters of water will I form? So if I take 2 liters of hydrogen, 1 liter of oxygen, how many liters of water will I get? So 2 liters of hydrogen, 1 liter of oxygen yields how many liters of water?
Using all the time.
Well, use whatever. How many liters of water? Will I get 2 liters of water? So 2, 1, 2. Will I? How many atmospheres of H2O liquid will I get? Will I get 2 atmospheres? Is it 2, 1, 2? 2, 1, 2, right? No, why? It's a liquid. Now, if this were H2O gas, true, true. But since it's H2O liquid, it's false, because a liter of H2O liquid is 18 milliliters. A liter of H2O gas is 25 liters. It's a huge difference, right, between the density of the gas and liquid. All right, so do you see we got to rapidly interconvert from both, because we use both all the time. And if you're not comfortable with using both, then you just got to drill it. Drill it until you're comfortable.